Okay, so in this next tutorial, we are going to build a wide flanged beam. And then later in another tutorial, we're going to take that and show you how configurations in SolidWorks works. So with the wide let's try that again. With the wide flanged beam, we're going to exploit symmetry to simplify the model as much as we can. So let's just jump right in here. Let's start a new model. So we've got a part. It's going to start a new part here, just like everything else. And right off the bat, let's save that. And should have had this all set up, but that's okay. So week 3. I like to save all these, and I encourage all of you all to save these too, because we can use them later and you can refer back to them. So we'll call that a wide flanged beam, and we'll save that. Okay, so let's start by drawing the initial sketch. So I'm going to do this on the front plane, and we're going to take a look at it. Now, I do want to make it completely symmetrical about everything. So the X, Y, and the Z. We'll accomplish the Z by the way that we extrude it out. But since we are centering everything up on the X and the Y, I'm going to use our center lines. I'm going to tag them to the origin. I get my horizontal one there. Tag it to the origin, and now I've got a vertical one there. Now you see that I've held up that line to that little yellow vertical appeared, so that would automatically put the relation in, so I don't have to worry about it. And so there we go. So we have our center lines, which are construction lines. And so now what I want to do is I'm going to build my beam. We know what a beam looks like. It's an I-beam. So what I'm going to do is I'm just going to sit here and I'm going to draw 3 rectangles, and then we'll end up putting them together. Now notice I'm not spending too much time to really make it look like what it is. I'm just slapping down some geometry because I know that's kind of what an I-beam looks like. And from there, we're going to sit here and we're going to start constraining this guy. But one of the things I do want to do is I want to make this just one cross section through here. So right now everything it's tagged together, so it moves around. I do have this line through here. SolidWorks will allow you to extrude multiple sections now. That's not always been the case, but let's just turn this into one section. The way that we do that is we have trim. Trim allows you to take out lines, trim to closest, trim away from outside. You have a bunch of different options here. I'm just going to go through the power trim, and basically I'm going to draw a line straight through here. And so what I'm doing is I'm just cutting this open. Now, did you notice how it went from gray and went to white for a second? And that's because I did not have an enclosed cross section, because I still had this little line here. And then when I got rid of that, it went back to gray. That means, okay, well, now I can extrude this because it's a closed section. So let's start adding some of our constraints here. I'm going to play with one that we had before, and we're going to go right back to symmetry because that's a great one. So I'm going to make things symmetrical about these axes that I drew. As I said, we are going to be using symmetry a lot in this model anyway. Okay, so now everything's symmetrical about those points. These outside ones need to be symmetrical about the center too. So we're going to pick those lines, we're going to pick that, and then we're going to make those all symmetrical. Now I could make these ones down here symmetrical about it if we wanted to have a different size beam, but the I-beams, they're going to be the same. So what I want to do is we're going to take these 2 lines, we're going to make those collinear. Notice I got that dashed line in there. All that's doing is saying, oh, this is all the same line. We're only using 2 parts of it. And then we'll do the same thing on the other side, make it collinear. Notice we're doing all of this before I even put dimensions in, because I want to have it set up to where then I can just slap the dimensions on and be done with it. Okay, so another one that I'm going to put is this line here and this line here. I want them to always remain the same distance from the same thickness. I'm going to put the equal constraint on those. And so what that's going to do is that'll make those completely equal. Should have made the it should have changed already. I don't know. Do I have that over constraint? Let's go take a look at that. So we got this line here, this line here. Oh, I guess I did not click on that. So now I've made those equal, so those will stay the same size. I do not have to do that to these two lines because they're bounded by the collinearities of the other sections. So I believe that is all the constraints that we are going to need. I mean, obviously we're still unbounded. We have to start adding some dimensions into that. So let's take a look, and I got to look at which beam we're going to make here. We're going to make a W8 by 31. So dimension D, which is top to bottom, that needs to be 8 inches. And notice part of it went black because it's fully constrained. So the flange width is 7.995. So from here to here, it comes up 7.995. And you can see that things are starting to come to shape. Flange thickness is this guy right here. So now we are looking at 0.435. And notice we've only got one dimension that is not fully constrained, and it's this one here. And that would be our web thickness, which is 0.285. So there we go. We have our I-beam there. 4 dimensions completely defines our beam. So everything's taken care of there. And what we need to do now is we need to extrude it. So our sketch is done. I'm going to hit here to exit the sketch, complete the sketch. There's our beam. So let's go to features, and we're going to extrude this out. Notice we've only got the one section there. SolidWorks goes, okay, well, this is the only thing we've got. Now we're going to make it 12 inches deep. Now, as I said, though, we want to exploit symmetry here. So instead of blind, we're going to do midplane. And so all midplane does is it goes, okay, we're going to extrude it out 12 inches, but from the middle. So it's almost like they're extruding it out 6 inches from each side. You'd get the same effect if you'd went 6 inches one way and then did a second direction and 6 inches that way. But we're just doing it from the midplane. And there we go. We have a nice, solid I-beam that's all put together. So let's put a material in on it. So edit material. And we want ASTM A36 steel. It's a good one. We use this a lot in strength of materials because it's got easy to work with properties for the equations. And so there we go. I have ASTM 36 steel. So what I want to do now is let's just take a look at some of the properties. We go over to evaluate. I pull up the mass properties of my beam. So we can look at things, the volume, the mass. It's a 31 or 30.59 pound of beams. It gives us all of our configuration data here, density, which it pulled from the material guide, surface area, volume, all great stuff, all good things to know. So why 4 dimensions? Why do I think that's an important thing? It's easy to modify. And as we're using SolidWorks, the thing that we always want to remember is we want things as easy to modify as possible, because that's really where the power in this whole 3D modeling system comes out. And so when you only have 4 dimensions and everything's set together well, it's easy to calculate out. And so you can look at things, you can you can look through this and play around with everything. You've got your display manager here where you can go into scenes and play around with that. You can play around putting decals on things if you really want. This is all stuff that I'd recommend just playing with at some point. You can bring up the manager. What I'm doing right now is I'm applying a matte steel appearance to the part. And unfortunately, with the video card that my laptop here has, it's not really coming out as pretty as it could. But anyway, that's all stuff to play with. In another video, we will be using this beam to show you how configurations work.